Now in this video we're going to continue to work with our hyperbolas, and this time we're going to look at how we can write the equation in to one of these standard forms. So we're going to look at one example here, and we're given the equation 9x squared minus y squared plus 54x plus 10y plus 55 is equal to 0. So if we notice here, this equation is not in standard form, so we want to rewrite it so that it looks like one of these forms up here. Now to do that, we want to get our x terms together. So I'm going to collect this together so we have 9x squared, and then we have a plus 54x. And I'm going to group our y terms, so then we have a minus, excuse me, we have a minus y squared, a positive 10y, and then we have our constant term of 55, which I'm just going to subtract that to move it to the other side. So if we subtract it, it'll become a negative 55. And now our goal is we want to write this 9x squared plus 5x. We want to be able to write this as a perfect square, which means we want to be able to factor this something like this, where we end up with, say, x plus 2 times x plus 2, which we could simply write as x plus 2 squared. So the question though is how can we do that? And we need to figure out what can we add on to make this a trinomial so that we can factor it. Because again, we want to fit it to either x minus h squared or this y minus k squared. In this case, we have our x, so we want to come up with an x minus h squared. So in order to do that, we're going to have to use a technique called completing the square. So if we're going to complete the square, and this is where if you had your quadratic or equation ax squared plus bx, a lot of times we note the coefficient of x squared, we refer to that as the ax, and then for x that's referred to as b, and then if you had a constant we would call that c. But what I want to focus on is this particular coefficient of our x term. When we're going to complete the square, we're going to be using this coefficient here of b. Now in order to complete the square, we look at this first 9x squared plus 5x, and we need the coefficient of the x squared, which in this case is 9. We need that to be a 1. So if we're going to change this to a 1, and let's see, I didn't copy this down correctly, this should be plus 54x. So if we're going to make this a coefficient of 1x squared, we need to factor out the 9. So that's what I'm going to do. I'm going to factor the 9 out of the 9x squared and the 54x. Now notice I'm not going to factor out the x, even though we could do that. I just want to take out the 9 because I want this to have a coefficient of 1. So factoring out the 9, we'll be left with x squared plus, whoops, go back to the other color. We take out the 9, we would get x squared, and 9 into 54 would be 6, so we're left with 6x. And I'm going to leave a little bit of space here for the parentheses because we want to figure out what do we need to add on for this trinomial so that it is a perfect square. Now here we have y squared, and actually it's a minus y squared plus 10y. So we need to be careful, and we want to factor out the negative sign. So if I pull the negative out, then this would be a positive y squared. But if we take a negative out of the 10y, that's going to make that a negative 10y. And we're going to leave a little bit of space for what we need to add on. Now notice when I factor out the negative, because if we distribute the negative back in, if we were to distribute this, we would get a negative y squared. And that's what we have up at the top. And a negative times a negative would give us a positive 10y. So now we have accomplished our goal. We now have a coefficient here of 1x squared and a coefficient of 1y squared. So now if we want to continue to here with completing the square, we're going to take the b value, which is the coefficient of the x, and we're going to divide that. Whoops, let me move over here. We're going to take the b value and divide that by 2. So for us over here, that means we're going to take 6, divide that by 2, and then we're going to take that quantity and square it. So if I take 6 divided by 2, which would be 3, and then 3 squared would be equal to 9. So we're going to add on a 9 here. Now, before I forget, notice here I didn't bring down my equals where we're equal to this negative 55. Now, this is the point where you need to really be careful. We put a plus 9 here, and we realize that we can't just come along to an equation and change it by adding 9. We also have to do that to the other side. But my question is, where did we add this 9 in relationship to the parentheses? The 9 is on the inside of the parentheses. Well, what's on the outside of the parentheses? We have another 9 out front that we factored, which means this 9 is going to be multiplied by the 9 that we added on the inside. So therefore, we would get 9 times 9, which is 81. So by putting the 9 on the inside, we really didn't add just a 9 to the problem, we added 81. So that means we have to add an 81 to the other side of the equation. Now we're going to do the same thing. But we're going to have to do the same thing over here for the y squared minus 10y. So we would take, once again, the negative 10, divide that by 2, so that's going to give us a negative 5, and if we square that, we would end up with a negative 5 times a negative 5 is a positive 25. So we're going to add 25. And once again, we have to do the same thing. What's out in front of the parentheses? The 25 is on the inside, so that negative we factored is actually going to be multiplied by the 25. So we really didn't add 25, we really subtracted 25, so we have to subtract 25 on the other side of the equation. So now we're ready to factor. We can bring down the 9, and x squared plus 6x plus 9, that's going to factor like this, and we would get x times x was x squared, and how we get 9? Well, that's going to be 3 and 3, so we're going to get x plus 3 and x plus 3. And we know that's going to happen because we completed the square, which makes it a perfect square. So we're looking at x plus 3 squared. Now, if you have a hard time factoring this, the easy way that we know where the 3 comes from, if you go up here, what was the b value? Our b value was the 6. Well, half of a positive 6 is a positive 3, so therefore this factors to x plus 3 squared. So over here, if we apply that to the same thing here, we have minus, and we know that we're going to have a perfect square, and we know it's going to be y. What's half of a negative 10? Half of a negative 10 would be a negative 5, so that means we're going to get y minus 5 quantity squared. And then, of course, we have a negative 55 plus 81 minus 25, and all of that is actually going to equal to 1. So now we're getting very close. This is getting closer to looking like this standard form, x minus h squared over a squared. So we need to get rid of the 9 that is here out front that we factored. Now this might be a little bit tricky how we do this. And this is where you recall when you divide fractions, what do we do? For example, if we had, let's say, 2/3 and we were dividing by 4/5, remember when you divide fractions, we multiply by the reciprocal, so the reciprocal here would be 5/4. So we want to do the same thing, but we're going to do this reverse. In other words, if I had 2/3 times 5/4, couldn't I rewrite this back to 2/3 divided by the reciprocal of 5/4, which would be 4/5? So instead of going from division to multiplication, we're going to rewrite the problem from multiplication into division. So over here, we can think of this as being 9 times x plus 3 squared. All of this is over 1. Well, this 9, we can rewrite it as x plus 3 squared. And what's the reciprocal of 9? Well, 9 is 9 over 1, so the reciprocal would be 1 over 9, and we can put that in the denominator as 1/9. Minus, and over here we just have the y minus 5 squared. And we can write it, if not, I mean, this is understood then to be over 1, and all of this is equal to 1. So once again, let me kind of review here. If we had x plus 3 squared over 1/9, we could multiply by the reciprocal, which would make it 9 over 1 to move it to the top. But what we did is we wanted to get the 9 from the numerator So we divided by the reciprocal, which would make it 1 over 9. So here we actually have the standard form of our equation. And I'm not going to go through all the details here, but once we get the equation in standard form, we now can identify the center, which would be -3 and +5. And then we have our a squared is 1/9, b squared is 1. And of course, we could continue to find c squared and also the vertices and foci. So what I want you to realize is if the equation that we're given here is not in standard form, most likely we're going to have to use completing the square in order to put it in standard form, and that may require that we have to factor out, like we did here, because we want to make the coefficient of the x squared 1, and if we have the y squared, that also needs to be a coefficient of 1. So keep that in mind as you're going through this process of completing the square to put your equation in standard form.